Hello and welcome along to another lesson with Mr. Burns. In this lesson we are going to convert fractions to percentages. Okay, so initially we're going to do this by making equivalent fractions. Okay, so we've got 1/4 here, 4 equal parts of which you have 1. We have made equivalent fractions by multiplying the numerator and the denominator by 2 and 3. Now to convert into percentages, we need to have the fraction out of 100 equal parts. Okay, so 4 multiplying 25 will give us 100 equal parts. This then leads it to 25%. Okay, so 100 equal parts, of which you have 25, is 25%. Okay, now the second example is 1/5. Okay, so 5 equal parts, of which we have 1. Okay, so we can make equivalent fractions by multiplying the numerator and the denominator by the same number. 2 divided by 2 is 1. Okay, so 1 times 2 is 2, 5 times 2 is 10, right? We can continue that on, we can keep doing that to see what we eventually get, what number we have to multiply by to get to 100 on the denominator. Okay, so looking at the technique there, we're multiplying both the numerator and the denominator, so making that really explicit. Okay, so we can continue that pattern on, but what we want to look at is how do we get that into 100 equal parts? What number do we need to multiply 5 by to get to 100? 100. Okay, so maybe you're thinking 5p's. How many 5p's in a pound? We've got 20 of them, so 5 times 20 is 100. Okay, so multiplying the numerator by 20 gives us 20. So 100 equal parts, of which you have 20, is 20%. Okay, so the denominator has to be 100, right? You have to find the value that you multiply the digit on the denominator by, okay, to get to 100. So, other examples, non-unitary fractions. So 3/10, what do we have to do to multiply 10 by to get to 100? It's 10. So if we know that, then we have to apply that same rule to the numerator, okay? So 100 equal parts, of which you have 30, is 30%. Okay, let's look at another non-unitary, 2/5. Okay, so we saw 1/5, which was 20%, 2/5, we're thinking 40%. Okay, so what we're multiplying 5 by to get to 100, we're multiplying by 20. 5 times 20 is 100, 2 times 20 is 40. So 100 equal parts, of which you have 40, is 40%. Okay, so if you had a test score and it was 40 out of 100, easy percentage, okay, 40%. Now let's look at a trickier one. Okay, so if you've grasped that idea, think about what do I need to multiply 8 by to get to 100? Doesn't fit as nicely in as 10 and 5 and 2 and 4 and all those kind of rounded numbers which are factors of 100. Okay, so let's think about a strategy, right? If we're working with the 8 times table, let's write down the 8 times table, right? That's a good starting point for any multiplication. Okay, what numbers there are going to help us? Will 16 help us? Will 24 help us? Will 32 help us? And so on. Now, looking at them, that's up to multiplying by 10. Ends in a 0. 100 ends in a 0. It's got 0 ones. 40's got 0 ones. Let's work with 40 just now. What would we have to multiply 8 by to get to 40? That would have to be 5. Okay? And there's quite a few strategies from here, right? Multiplying 40 into 100, think about that. So we're currently sitting at 25 over 40, right? 40 equal parts, of which you have 25. Is 40 a factor of 100? It's not. So what can we do to help us get to 100? Well, we could simplify it so that we get a factor of 100. A factor of 100, which will help us here, is 20. Okay, now even though that is not a fraction now, we have got a denominator. right, which is over 20, which is 20 is a factor of 100. Okay, so 12.5 with our line and the 20 on the denominator, then we can multiply that up. Okay, so 20 times 5 will give us the 100, and then that will give us 100 equal parts. Okay, so there are a few different ways of doing this. Right, this is one method which I'd like you to see. Okay, now multiplying these decimals by 5, why don't you take the time, standard algorithm, you're just hour sum or area modelling, and then we have 62.5. Okay, so we wouldn't normally write fractions with the decimals, but because we're converting it into percentages, then we want to have that 100 equal parts. We want to have that denominator as 100. Okay, so 5/8, 8 equal parts of which you have 5 is 62.5 of 100 equal parts, which is 62.5%. Okay, so that's doing that method using the equivalent fractions so that you get the denominator out of 100. Okay, now let's look at another way of doing this. Right, so this 5/8 means 5 divided by 8. Okay, so we go to a division sum, right? And I'm going to be quite specific here in how we do this, right? We're not going to draw that line under the 8. Okay, we're going to relate this to our area modelling. Okay, so this here, we are reverse area modelling. Okay, so that there is our answer, right? 8 multiplying what gives us 5, right? So think about the area modelling that we do. Right, so we're doing 5 divided by 8. Right, we're going to add the zeros, the point and the zeros, because 5, as you know, is equal to 5. 5 is the same as 5.0, 5 is the same as 5.00, and so on and so forth. Okay, so we can add as many zeros because they are there for the placeholder, and if there's nothing there, then we don't need to write it. Okay, but this will help us here. So 5 divided by 8, 0 remainder 5. And once again, if you're not sure about your times tables, let's get that listed down. Okay, go as far as you need to. 1, 2, 3, 4, 5, 6. So 50 divided by 8 is 6. 48 up to 50 has a remainder of 2. Okay, so let's put the 2 in the hundredths column. Okay, so 20 divided by 8 is 2. 16 up to 20 is remainder 4. Okay, so what we'll have to do here is add a 0 for the placeholder in the thousandths column. Okay, and then 8 into 40, or 40 divided by 8, we get 5. Okay, now it's very important at this point here that you then understand what you have got. Okay, so thinking about your place value, right, 0.625, right, as in its decimal form. Now, going back to basics, let's put the place column headings down. We've got our hundreds, our tens, and our ones column. So we'll do that units. Right? I know that can be a wee bit of a mix-up with units and say volume and measurement. But that's your ones column. Decimal points there, so we've got 0 ones, we've got a decimal point, we've got 6 tens, 2 hundreds, and 5 thousandths. Okay, so what we want to know is we want to know how many hundreds we have. Right, so we've got 62 hundredths. Right, I know the 5 just now, just so we've got a grasp of what this represents. I've got 62 hundredths. Okay, but we've not actually got only 62 hundredths, we've got 62.5 hundredths. And this here represents 625 thousandths. Okay, so if we simplify that, dividing the top and bottom by 10, we've got 62.5 hundredths. Okay, those are exactly equivalent. Right, so we're multiplying that, and just the same, simplifying your fraction because you want it as hundreds. 100 equal parts. If you've got 100 equal parts in the numerator, represents the percentage. Okay, so 62.5%. The same. So give that a good practice. Okay, you can do that on the calculator as well. Okay, thanks for watching then. Very important.